Hello, this is Colleen Tedderton. I will be discussing with you today the standard that I will be presenting. This is a common core standard for an Earth and Environmental Unit in North Carolina, and this is standard 1.1. The big idea in this standard is the Earth's role as a body in space. This is typically a grade 9 through 12 high school class course. Mostly we have freshmen that enter and take the Earth and Environmental Science course. Occasionally we will have 10th graders, and sometimes we'll have upperclassmen that need to meet a requirement for graduation that will come back and take an Earth or an Environmental Science course. So what I do is I present to my class a notebook, and this is the astronomy unit, as I said, the standard 1.1. And so what I put here is I say, how do the origins and laws of the universe influence changes observed on Earth? And I also include in my notebook so that they will be able to look at this as they proceed through their worksheets in the notebook. The students will be able to, and I'll list them, the student will be able to analyze evidence of the Big Bang Theory based on motion of celestial bodies. Students will be able to compare and contrast geocentric and heliocentric models of the universe. Students will be able to predict planetary motion based off an orbit simulation in comparison with Kepler's 3 laws. Student will be able to compare and contrast the time and effects of Earth's rotation, revolution, precession, and nutation. Student will be able to hypothesize the approximate location of 2 bodies barycenter based on their masses. And lastly, students will be able to analyze tidal effects based on the location of Earth, the Moon, and the Sun. So that's what they will be learning throughout this standard, which is 1.1. What I have proposed as 2 exercises that will help them is first a barycenter lab that we talked about here, what the students will be able to. This is a lab that involves a dowel rod and varying sizes of Play-Doh on either side, and that dowel rod hangs from a string. And what we do is we adjust the dowel rod string with the different masses to see where it balances. That explains to the student how masses hold each other in place in the universe. So if something had a bigger mass and something had a smaller mass, you would adjust the string and they measure the distance. So that's the barycenter lab that we do. The other laboratory exercise that we do is called a motion simulator lab. And I start this off with where I have a student stand in the center of the room, and I have students placed further and further away, and I ask them to walk in a circle. They'll quickly see that the person closest to the person in the center, which represents the sun, can move much faster around that central location. The person on the furthest side of the room, it takes much longer for them to walk all the way around that center person. So they understand the orbit of the planets and why Earth, we have our 365 days, and planets further out take much longer to get completely around the sun. After they do that, they go into their technology devices and they do a simulator lab via WebQuest, and they can manipulate the planets, they can move them, so that reiterates that fact. So those are the 2 activities that I have planned for this unit. Thank you.